Welcome to the Virulent Vortex, a podcast in which we discuss infectious diseases across scales, from pathogens, molecules to population pandemics and everything in between. My name is Jaap de Rode. I'm a biology professor here at Emory University, and joining me today is Amber Coates. Amber is a graduate student in the microbiology and molecular genetics program here at Emory, and will be joining us to talk about her research. Amber, welcome to the show.
Hi, thanks for having me.
All right, so Amber, my understanding of your research is that it's focused on COVID, and then particularly something about chronic infections.
Yeah, so there has been this outstanding question given the pattern of emergence of variants of concern, such as Omicron, where they seemingly come out of basically nowhere.
Okay.
And so there's been this huge question of where did these viruses evolve? Mm-hmm. And so our idea, which is the most common thought process at this point, is that these variants evolve over time within a single chronically infected individual.
Okay.
These are going to be the potentially immunocompromised people who have been infected and they have COVID infections for weeks to months to even years. And so they're infected for really long times, and it gives ample time for the virus to evolve into a new variant.
Yeah. So to unpack this a little bit, variants of concern. So you mentioned Omicron, and we have had Delta, and I think a lot of people are familiar with these variants, because these are the ones where we think we're done with COVID, and then there's a new variant that can infect us even if we had the vaccines. Is that what these variants are?
Yes, exactly. So it's these variants that are very genetically distinct. Uh-huh. So they're very different, and they have what's known as immune escape properties. So they are have evolved antigenically so that the immune response built up if you were, say, infected by Delta, you're no longer protected from, say, Omicron. Yeah. So they're very different.
Okay. And
why they're different, where they come from, it's a very big question in the field.
Yeah. Okay, and then talking about these lung infections. So this is interesting because, those of us who have had COVID, and that's probably a lot of us at this point, is, you test positive and you keep on testing, and then hopefully within a week or 10 days or 2 weeks, finally you get that lack of that, on that stripe on your home test kit, and you can go back to work or go back to school. But you're saying some people have it much longer than that.
Yes. So it's typically the people that have weakened immune systems. Okay. So it would be, for example, people that are infected with HIV, people that have been treated for cancer, under chemotherapy, things like that. They have a weakened immune system, so their body isn't able to get rid of the virus.
Right. And so this may be months, you said it can even be years. And so during this time, these viruses are doing their thing, they're replicating, and then they have mutations. And so your hypothesis is that during this period, you can get this evolution of new variants, which then start spreading to other people.
Yes. Yeah, so we've hypothesized that over time, it's the perfect environment for the virus to just continuously make more of itself. And each time it makes more, it's going to create these mutations. And over time, you're going to get this new variant within this one person that is drastically different. Yeah. And then at some point, that person transmits it to another person. And once that happens, it can spread throughout the whole world if that's what it's going to do, or it could die out. But it seems that the viruses that do get transmitted tend to be a little bit more capable of spreading.
Yeah. So so earlier you said, really the question has been for these variants of concern, these new variants that can reinfect, that, you just didn't know where they were coming from. And so you're basically hypothesizing that they're basically lurking within individuals that have these really long infections.
Yeah.
So how do you address this question? How do you answer it? So that's a hypothesis. Now you're testing it. How do you do that?
Yeah, so there's a lot of evidence suggesting that this is the case of where it's coming from. For example, just based on the genetic differences, it lines up with it. But the way that we're going to be testing this to see what specifically is driving this is we have a process where we're able to do simulations of viral evolution. So we can see how the virus is going to evolve over time, over the course of one person's infection. Mm-hmm. And so we can see what mutations occur, how fast they occur, whether it improves the virus's ability to infect human cells, to transmit. It's more so we're trying to understand, why are they coming from this? Why is SARS-CoV-2 not evolving like flu, where it continuously accumulates new mutations that results in us having to have a flu vaccine every year, where it's continuously changing. Whereas SARS-CoV-2 seems to be like, it's this one variant. So you said Delta's evolved, or Delta is infecting people for a couple of months, and then all of a sudden you have this new variant that takes over.
Yeah.
Why is this the case?
Yeah.
Where does it come from? Why is it doing it? If it comes from a chronic infection, why is it evolving in a chronic infection?
Yeah.
What's causing it to do that?
Yeah. Yeah. So the difference between flu and SARS-CoV-2, you say, the flu virus keeps on evolving. So what we have today is essentially the offspring of viruses from last year.
Yes.
But you're saying Omicron is not the offspring of Delta. They're completely independent.
Yes.
And they came from individuals that had these really long infections.
Yes. And that's a pattern that isn't very often seen. And so it's not very well understood. And so we think that it comes from chronic infections. And the reason that we think that is because when you look at Omicron versus Delta, Omicron actually, it's the offspring of the variant called Gamma rather than Delta. But when Omicron emerged, Delta was the strain that was circulating.
Right.
And so that's not seen. And there's a lot of genetic differences between the two. Yeah. And it requires that there is some place where it had time to accumulate all of those mutations. And we don't know why or where.
So what are some of the, applications or uses of this for our individual and public health? So how are we going to use any of this to, prevent us from getting sick?
Yeah, so by understanding what types of mutations drive this and how long it could take, you could be better prepared. Say if we can anticipate that it's going to take X amount of time for a virus to evolve within a single infection, and we know that Delta occurred a few months ago, say it takes 6 months for this virus to evolve to a new variant, we could expect that in a few months, we could have a new variant emerge. Yeah. And so it just allows us to better anticipate when we could expect something, as well as the way that the virus has evolved, what type of mutations it could have. And it's just allowing us to better anticipate what might happen.
Yeah. Well, Amber, it was a real pleasure talking to you and learning about these long chronic infections. I learned a lot and very intrigued about these variants.
Thank you.
So thank you so much. Thank you for watching this episode. We hope to see you for the next one.